Today we are going to discuss about the topic hazard analysis and critical control point system. Hazard analysis and critical control point system is a management system in which food safety is ensured through the evaluation and removal of biological, chemical and physical hazard from a raw material to the final finished product. There are basically 7 principles in case of hazard analysis and critical control point system. First one, conduct a hazard analysis. Second one, identify critical control point or CCP in the process. Third one, establish critical limit. Fourth one, establish monitoring procedure. Fifth one, establish corrective action. Sixth one, establish verification procedure. And seventh one, establish a documentation system. This is a flow chart or steps involved in a hazard analysis and critical control point system, in which a seafood product from the initial stage, that is receiving from the raw material to the final production system, all these products are combined or go through these different steps. First one is conduct a hazard analysis. This is the first step in case of hazard analysis and critical control point system, in which we are preparing a flow diagram that includes receiving of raw material to the final finished products. All these steps comes in between the receiving and final finished products. We are making it and evaluating any chance of occurring a significant hazard in any processing step, and recommending or making remedial measures to remove the significant hazard from the final finished product. And this is the first step in case of hazard analysis and critical control point system. Second one is identify critical control points or CCP in the process. A critical control point is defined as a step at which control can be applied and is essential to prevent or eliminate food safety hazard to reduce to an acceptable level. For each significant hazard, there will be a CCP, and we are applying that CCP to make the product more safer. In case of bivalves, the example for certain significant hazard is, in case of bivalves, a paralytic shellfish poisoning and diuretic shellfish poisoning are the common hazard found in case of bivalves. In case of cephalopods, cadmium and lead are the biological hazards found in cephalopods. And in case of other aquatic organism, antibiotic and pesticide residue are the common significant hazard found in freshwater or aquarium or aquaculture species. Next is establish a critical limit. So in case of biological pathogen and physical hazard, the critical limit is 0 or absence, and in case of chemical hazard, appropriate tolerance level has been established under the USFDA or Code of Alimentaries Commissions. Critical limits for certain seafood-borne hazards are in this table are listed in the table. In case of paralytic shellfish poisoning, the critical limit is 80 mg per 100 gram of the sample. In case of diuretic shellfish poisoning, it is 20 mg per 100 gram. Staphylococcus toxin should be absent. Botulinum toxin should be absent. Lead in case of cephalopods is 0.5 mg per kilogram. Cadmium 0.5 mg per kilogram. Mercury 0.1 mg per kilogram. Pesticides 0.5 mg per kilogram. Antibiotics, hormone residue, sanitizers and lubricants, pathogens should be absent. Parasites should be absent. Foreign matter, fish hook, metal fragments should be absent from the final finished product. So these are the critical limits as per the HACCP or hazard analysis and critical control point system. Next is establish monitoring procedure. In this step, procedures to ensure that significant hazard at appropriate CCPs are always maintained within the tolerance limit established by directly or indirectly testing or observing the significant hazard. Next is establishing a corrective action. In this process, if we found a certain significant hazard is out of control, we can rectify that. By this step, we can rectify that. In case of undercooking, in case of shrimps or other fish products, in case of undercooking, we have to maintain the cooking temperature at the appropriate levels. And in case of cephalopods, to remove the viscera, to remove the pesticides or other heavy metal contamination. And in case of bivalves, it is eviscerate, remove the viscera, or depuration process is given to remove the biological hazards. Then establish verification procedure. In this step, we are checking or calibration test done is together to review the actual analytical data which confirm the HACCP is working effectively and the products are safe for human consumption. Next is a documentation system. All the steps, that the initial step, that from the receiving of raw material and the different steps involved in hazard are documented for final verification. In case of hazard analysis and critical control tools, all details of GMP and SSOP also have to be finalized and have to be recorded in the laboratory for the verification of EU personnels. Thank you.